Okay, so linear equations and slope. I've got to change a typo here. Sorry about that. Okay, so linear function. A function whose ordered pairs satisfy a linear equation and can be written in the form the function of x is equal to mx plus b. Okay, that's a nice fancy way of saying it. Let's talk about it and what isn't a linear function, and I think then we'll get a better idea. So let's start with this one. Is this a linear function? Yes.
Yes.
That is in slope-intercept form with, it just doesn't have a y-intercept, right? What about this one?
No.
No, this one's different than this one. It's different because x is in the denominator. The graph of this one would look something like this.
Write this down. Or just pencil down.
No, you can write this down. You only have to say pencils down when it says on the board pencils down. Okay? Otherwise you can be writing. So this graph right here, this equation with the x in the denominator, looks something like that. Curvy line. It's not a linear function. Okay? What about this one? Yes, sir. Come on and get another one.
Wait, go back.
Go back.
You guys do the same one, so just straight.
Oh, there you go.
We'll problem solve it.
Excellent. Excellent problem-solving strategy. Fantastic. All right, so x plus xy equals 1. What about this one? What do you guys think? Do you normally see an x over here and an x attached to y?
No.
Let's think about this. If I were to try and put this in slope-intercept form, it'd look something like this. Then I would have to divide by x. Right? So this would actually be y equals negative x plus 1 over x. So that turns into something more like this, right? If you've got x in the denominator, that is not a linear function. So let's put that one over here. What about x equals 9?
Yes.
Yes.
Why?
Because x equals 9 means x is always 9. No matter if y is 1 and x is 9, y is 2 and x is 9, y is 3 and x is 9, y is 1,000,000 and x is 9. It's a straight line at 9. Right? What if y was negative 5? X is 9. That's why there's nothing with y in here. Because no matter what, this is always going to be on 9. All right, what about this one?
Yeah.
Let's pretend this is y and this is x.
No. Yes.
That's a quadratic.
No.
That's a no. Right? That's something that looks more like a U shape. What about, I'm going to erase this. What about this one? No, good. You have to. Think about it. This is the way I look at this. If x squared is something like this, isn't the square root of x the inverse of x squared? Right? So if it's the inverse, I'm going to say no and tell you that this equation looks something like this. Kind of like half of a u. All right, what about this one? Yes. That's just in standard form. What about this one? Doesn't matter. Yes. Yes. There could, and we're going to actually look at that in just a second. That's a good question. You guys okay with this? This is also, if I just pretend that this is x and this is y? What if it was the other way around? What if this was y and this was x? Right? Could you still manipulate it and turn it into slope-intercept form? Yes. Got it? You guys good? All right, let's continue. All right, pencils down. Write each equation in standard form. Let's just take this off right here. Okay, no state secret. Apply a strategy to convert into standard form. So this is in slope-intercept form. We're going to put it into standard form. All right? So in order to put it into standard form, I'm going to apply a strategy. Well, standard form does not have fractions. So I need to clear that denominator. So I'm saying to myself, I'm going to have to multiply everything. Let's see, let me rewrite it first. Y equals 2/3 x plus 1. I'm going to multiply everything by 3. When I do that, the 3 goes away, and now I have 3y equals 2x plus 3. Close, right? Almost in standard form. So I'm going to subtract 2x from both sides. Sorry. And now I have negative 2x plus 3y equals 3. But just like if you had, let's do this over here in the corner as a side note. What happens if I have negative x equals 3? The opposite of x equals 3? Isn't that the same thing as the x equals negative 3? Just apply a negative to everybody? So couldn't I just say, I'm going to take the inverse of each one of these, the additive inverse, 2x minus 3y equals negative 3. Standard form, for some reason, we don't like it when it's got a negative out there in front of the 2. So my final step is to identify A, B, and C. A equals 2. B equals negative 3. C equals negative 3 as well. Okay, so now it's your turn. Go ahead and do this one, and then I'm going to do it at the same time as you guys are doing it, but I'm going to hide it, and then I'll come back and show you what my answer is. Okay, everybody ready? Here's my answers here. A should be 1, B should be 3, C should be 15. Questions? Pretty clear? Okay, let's move on. Pencils down. Find the x-intercept and the y-intercept of the graph. I can.
What happened? Oh, never mind.
I added it to both sides, and then it became positive. Good question. Okay, pencils down. Find the x-intercept and the y-intercept of the graph. Let's uncover this. So find the x-intercept, the steps. Substitute 0 for y and solve for x. So that's what I'm going to do. I'm going to substitute in 0 for y and solve for x. So if y was 0, I wanted that a different color. Then I would have 0 equals negative 5x plus 3. Subtract 3 from both sides. This isn't going to be very pretty numbers. Negative 5x equals negative 3. divide by -5, divide by -5, and I get x is equal to 3/5. Go ahead and plot that. About right there. Substitute 0 in for x and solve for y. So I'm going to go ahead and kind of just skip down a little bit and say y equals -5. I'm going to substitute in 0 for x. And I get y equals, that just becomes 0, y equals 3. Go ahead and plot that. 1, 2, 3. Question. I took this original equation right here, and let's see. Let's turn it to black. And rewrote it right there. You see it? So this one right here is me doing this first step, substituting in 0 for y. That's what I did here, and solved for x. Then I plotted my x-intercept, which is right there. Then I substituted 0 for x and solved for y. So I put in 0 for x and solved for y. So my x-intercept is 3/5 and my y-intercept is 3. And since I know the intercepts, I now have 2 points and I can graph a line. It's just another way to do it. You should already know how to do this or have seen it, but not all teachers teach it this way. I don't like it because I would much rather use the slope-intercept form of an equation. But if you have something in standard form, sometimes it's easier to do it like this, which I'll show you in the next example. But the problem with it is that you're just guessing. On this one, I can see for sure that this is right. Y equals -5x plus 3. I know I have to go up 3, right, to start at the y-intercept, and then go up 5 over 1. Up 5 over 1. I can tell that this is right just by looking at this equation right here. But if it was in standard form like this, here's this in standard form. 5x plus y equals 3. If I were to substitute 0 in for x and find my y, and substitute 0 in for y and find my x, I would find these points, but just by looking at this equation, I couldn't tell you whether or not it was the right equation of the line. Does that make sense? So to me, this is better to use all the time, but you need to know that this is a possible way of doing this. Okay? Yes? Because in order to find the x-intercept, y has to be 0. And in order to find the y-intercept, x has to be 0. Right? Because I don't have, like, if I were to plot these points right here, this would be, the ordered pair would be 3/5, 0. When y is 0, that's what x is. It's a very good question. And this one would be 0, 3. See how that works? Good questions. Okay, you guys try one. I'm going to go ahead and do it with the screen blank. Okay, so here's my solution. I substituted 0 in for y. I got -5/2. Plotted it. Substituted 0 in for x. Got 1/2. Plotted it. Drew my lines. Questions? Yes. Okay, graphing fractions. So, in order to graph a fraction, isn't -5/2 really 2.5? Because 2 times 2 is 4, with 1 left over, right? If this confuses you, you could also do this. Two halves, and 1/2 all make 5 halves, right? And this is 1, plus 1 plus 0.5. You know how I do it sometimes too? If I'm looking at the graph, you can say 1/2, a whole, 2 halves, 1/2, 2 halves, 3 halves, 4 halves, 5 halves, right? Is that easier? If you think about it in terms of a half? Here, let's make it bigger and I can do it easier. So if I'm talking about halves and I need 5 of them in the negative direction, I would do, let me change my color so you can see it. I would go -1/2, -2 halves, -3 halves, -4 halves, -5 halves. Better? What, is that too simplistic? I thought it's a good way to explain it. Okay, let's move on to the next one. Let's talk about slope. All right, let's talk about slope, a rate of change that measures how much a quantity changes relative to the change in another quantity. So we're talking about changes in one thing compared to changes in another. So slope is rise over run, right? Or it's talking about this change, this change right here, the difference between my y-coordinate, there's a y-coordinate and there's a y-coordinate. This is your rise. The difference in those, or the change in y, delta y. You seen that before? Well, you should have seen it before, right? Compared to your change in x, the difference between your x values. What does that sound a lot like? Change in y compared to the change in x. So it is right. Distance formula, right? The distance from here to here, is that change squared plus that change squared, right? Remember that? Geometry? Yay, geometry. Okay, so I have it here too, y2 minus y1. You'll see I don't use these subs. Y sub 2 minus Y sub 1. I do it a little bit differently. And that's why I have this slide here, so that you can see. I don't expect you to do it exactly the way I do it, but you should be able to follow along and see what I'm doing. Okay? So if you want to use this standard formula, that is fine by me. I'm just going to talk about the changes themselves, the difference between two numbers. All right, so this graph right here, this line would be a positive. This one would be 0. This one would be, and you said you haven't seen slope, dude? That's why. Because as soon as you see slope, dude, you'll never make that mistake. You'll never make that mistake again. And this is undefined. Yeah. Okay. Slopes of parallel lines. Slopes of parallel lines are, think of two parallel lines. What do we know about their slopes? They're the same. Slopes of perpendicular lines are opposite reciprocals. Not only is a line, see, because if I had a line like this, then if I wrote it with that pitch right there in the opposite direction, it would not make it perpendicular. Is that perpendicular? This one needs to be a little bit steeper for it to be perpendicular, right? In order to make it perpendicular, let's say this line right here was 1/2. This line right here would be -2/1. This one's less steep. This one's the exact opposite. Make sense? Okay. So they are opposite reciprocals. These are perpendicular lines. All right, let's move on. Pencils down. So we are going to find the slope of a line that passes through each pair of points, then graph the line. So my first step, this is the way I do it, I set up a skeleton. Then I label, it says label you. Label your X's and Y's. I'm going to label my X's. Then I'm going to label my Y's. And I'm going to do like a little extra one over here. Let's just draw another skeleton up here. You don't have to do this one. I'm just doing this for fun. Okay, so let's talk about our X's first. My X's are -2 and 2. -2 and 2. Change in X is on the bottom or in the denominator. Change in Y is in the numerator. My Y's are -1 and -3, so I'm going to put -1 and -3. Now, how many of you only know it this way? I should erase this. Okay, so I'm going to do it that way up here too. I don't like this way, just because to me it confuses students and it takes you away from the concept. The concept is the change in Y. It doesn't matter if I put one Y first before the other, you're still finding the difference between the two of them, right? So, if I put my Y2 first and then my Y1, I would put -3 up here and then -1. And over here, my X sub 2 would be 2, and my X sub 1 would be -2. So I'm going to do it both ways. All right, so -1 minus -3. This becomes plus. The opposite of a negative is a positive. So then I have a 2 over. -2 and -2 make -4. If I were to simplify this fraction, it's -1/2. Do it up here. Negative and opposite of the opposite. -3 plus 1 is -2 over 2 over 4. The same slope, right? So as long as you just say, I just put them in the order I see them. -2 and 2, -2, 2. -1 and 3, -1 and 3. As long as you keep if you start with this one, you've got to start with that one. Okay? Doesn't matter. It's the same thing. All right, so I have a slope. I'm going to pretend like I don't know what one of these is, because obviously I can plot a line if I've got 2 points, right? So -2, -1. -2, -1. If I have a -1/2 slope, my slope is -1/2. So I'm going to go ahead and say up 1 over 2 in the negative direction. That's another thing. I always go up. Some people go down and to the right, always going to the right. I always go up because it's rise over run, right? So I'm always going to rise first. So I rise, and then I decide whether I need to go in the positive direction or in the negative direction. And in this case, I had to go in the negative direction. That's just how I do it. Okay? All right, so there's my line. Let's just double check. 2, -3. 2, -3. I think that would touch right there, right? 2, 1, 2, 3. My line's not exactly perfect. Question? Yes, sir. Find your slope. On your homework, it's just going to give you 1 point and give you the slope. I'm kind of incorporating two examples into one example right here. I can show it to you, yeah. It'll be easier than this for these kind of problems. So it'll just, for the homework problems, you'll have some like this and it'll say find the slope, right? So you would just use the slope formula to find the slope. Then on another set of your homework problems, they'll look like this. They'll give you the slope and ask you to graph the line. I just did, right here. I had a point to -3. I'll show you again. I did it with the other one though. Okay, so if I had this point right here, pretend like all of this is gone. We didn't have to do any work. All we did was, this is what's in your homework. Here's the slope, there's the point. So what I did was, I said -2, -1. -2, -1. I started at that point, and then I went up 1 and over 2. Done. That easy. See how I'm incorporating two different things into one example? Okay? And the only reason I'm doing it like that, you guys, is because I have so many examples to do today. All right? So I was trying to, like, how am I going to get through all of it in one shot? All right, so let's get rid of this and this and move on. Now you guys do one. Find the slope and then challenge yourself. Cover up one of the points and just graph it using one point and your slope. Make sense? Okay, so here's my completed example. Did you get a slope of 1? Does your graph look like mine? Good. Any questions on that one? Did you guys challenge yourself and cover up one of your points and try and graph just straight from the point? So what do I mean by that? I could have graphed these 2 points and drawn a line. Right? But what I was trying to get you to do was just plot one point and then use your slope to find your line. Okay? Yeah.
I think we should I don't remember the point.
You got -1. Did you find your error?
That's mine.
Did you draw your skeleton first? Did you see your mistake? Good. That's the best way to fix it, is to find your own error.
I got 1.
Okay, moving on. Pencils down. Graph the line through the given point that is parallel to the line of the equation. So, a few different things here. I have an equation, and I know parallel lines mean same slope, right? So if I find the slope of this line right here, that'll tell me the slope of my line. So what I'm going to do is I'm going to say x minus 3y equals 3. I'm going to go ahead and subtract x from both sides. We ran out of time fast today. Can I trust that you guys will pay attention if I have Matthew return those quizzes? You guys say that now.
Yeah.
I'm going to divide everything by -3. Y equals 1/3 x minus 1. So now I can see my slope. My slope is 1/3. So now that I know my slope, I can graph this new line. -2, 4, 1, 2, 3, 4, it looks like right there, and my slope is 1. Up 1 over 1, up 1 over 1. Thank you. It is 1/3. Why did I write 1? Who knows, right? Thank you for that. So I start here and I go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. There's my line. What would my slope be if it was a perpendicular line?
3 over 1.
-3 over 1. Okay. So my steps are convert the equation to slope-intercept form, identify the slope, plot the given point. I think we need to move on to perpendicular. Or would you rather just practice? You guys want to practice the perpendicular one? Because we have 4 minutes. All right, I'll do it. I'll find slope, dude. The bell's going to ring anyways, and then you guys aren't going to watch it. You're all going to walk out that door. But we'll see.
I'm gonna say.
Yes, you can keep that.
Is it
What?
really good?
Rip them apart. Okay, you guys do this one. I'll come up with the answer so that you've got the notes.
Or is it 3 good? 3.
No. These are not, I do not know what these are out of yet, but, no, it's not going to be out of 10. But if you did better on the test, I'll replace that grade.
Oh, it's out of 10?
No, it's out of more than 10.
There wasn't enough time to finish.
But I gave every class the same amount of time.
That was 3 out of 1.
So some people got it done.
What?
I think the highest grade was a 17.
Oh, it's out of 20.
You should put a curve based on the class.
I'm going to curve it.
What is this?
So the highest score in this class.
The quiz you took last Thursday.
The group quiz.
Yes, there was a backside. There was a backside?
Oh my god.
Oh, we're stupid.
We guys, we took like we messed up so badly. Oh,
Is there any way to make up that quiz?